Hello everyone, welcome to the online lecture of Vehicle Testing and Homologation. I am Milan Trivedi, Assistant Professor at LJ Institute of Engineering and Technology. Basically, in today's lecture, we are going to continue with our second chapter, that is engine fuel system and the emission testing. So let's begin with the concept of the air consumption measurement. Whenever we talk about this particular air consumption part, it becomes a very difficult task because it is very easy to measure some of the physical quantities such as solid which is passing, some of the liquid which is that is fuel which is passing to the particular engine. That is very easy to measure out. But whenever we talk about this particular air consumptions, it becomes a very difficult task to measure. So one of the easiest technique to in order to evaluate the amount of air which is taken inside is the air box consumption measurement method. So let us have an idea about that. How does this air box method work? But in order to understand that particular concept in a proper way, we need to have outlook of the proper understanding of the particular construction part. So in short, we are having one this kind of surge tank, right? That is a box type of appearance. That's why it is called as a airbox consumption method. This particular airbox is actually attached with a thermometer which will measure the particular temperature of air which is taken inside through the particular orifice plate, that is a kind of opening which is present in that particular air box. That from that particular opening the fresh air will be taken inside and that would be supplied to the particular engine. Now at the bottom part we are having a manometer as well which will indicate the amount of pressure which is present in that particular air. So before passing the particular air to the engine, we are having the measurement of pressure as well as the thermometer, and through the particular area through which it is entering, that is the orifice area, is also been monitored, right? So these three physical quantities are being monitored before passing the air to the particular engine. Now let us understand how to evaluate the particular consumption of air. For that we are having already that formula, that volume flow rate is equal to CD A into under root 2G delta HW. This head of water is actually required to convert it into the form of head of air. That can be easily converted from this gas law. PV is equal to MA into R into T. This R would be constant, temperature we are already measuring, right? So the naturally the mass of water would be the PV P divided by R into T. This delta H is equal to, sorry, head of air is equal to delta H by 100 into mass of water divided by mass of air. So all the quantities which you are having through this, we can convert this delta HW in the form of head of air. So we are having this head of air, G value is 9.81, CD is constant, A in this particular formula, that is area of orifice, that depends on the amount, the shape of orifice which we are using. Suppose if we are using a circular section in the air box through which the fresh air is taken inside, then obviously the area would be pi r square. Suppose it is a like of rectangular opening, then we need to take the amount of height into the width of that particular opening. So from that way we can easily have a physical quantity of that volume of air which is taken inside the particular engine, right? That's all about that particular air consumption measurement. Now let us understand the exhaust gas measurement technique. This plays a vital role whenever you talk about any of the measurement technique of the vehicle, because directly the impact of this particular measurement is on the Bharat stage norms in India, right? So in India, we are actually most of the times we are using the non-dispersive infrared analyzers. But apart from that, we are having number of different techniques through which we can measure the amount of exhaust gas which is present, right? By this particular measurement word, I literally mean that the suppose exhaust gas is there, then how much constituent of carbon monoxide, carbon dioxide, NOx emissions, particulate matter emissions, hydrocarbon emissions are present in that particular gas, right? That is actually required to be evaluated. So let us understand that which are the different techniques through which we can have an idea of the exhaust gas measurement. The first technique is the non-dispersive infrared analyzer. Through this particular technique, non-dispersive infrared analyzer, we can easily evaluate any of the particular constituent of gas which is present in the exhaust gas. So let us first of all understand the setup part. In this particular setup, we are having first of all the parabolic mirror. Now the focus point of parabolic mirror is actually connected with a light source. This light source would be not a normal light source, but it is emitting a infrared light. So from this particular focus point, once the light is emitting on the parabolic surface, it will convert all the dispersed rays into a parallel form. Now this all the light source are in a form of parallel rays. Now this parallel rays is allowed to pass through the two different chambers. Above one is a sample gas chamber, below one is a reference gas chamber. In this particular reference gas chamber, we are keeping inert gases. That inert gases can be a helium, nitrogen, such kind of gases would be kept in the reference gas. In this particular above sample gas chamber, we are filling the exhaust gas, of which the constituent is required to be measured, right? That particular exhaust gas would be kept in a sample gas chamber, and in the reference gas chamber we are keeping the inert gas. Now this inert gas would not react with the light which is passing through them, but the sample gas, the different gases which is present in that particular sample gas would have a tendency to react with that infrared light. And all of the different gases have a different tendency. That, say for example, carbon monoxide, if the infrared light is of 3000 wavelength, then it would react with that, it will absorb the energy, and because of that the temperature of that particular gas would be raised, right? That the rise in temperature would be measured with the thermopile particular sensor. Now this thermopile actually measures the rise in temperature, that how much temperature is there, that would be measured with the help of this kind of thermopile sensor. So obviously we can need to actually simulate that how much rise in temperature, that will actually indicate the value of carbon dioxide which is present. Now if you want to measure the carbon monoxide, we need to find out that what particular wavelength does that particular carbon monoxide absorb. That particular infrared light would be allowed to pass through the particular chamber, and it will absorb that particular light. Now the rise in temperature will be measured with the help of thermopile. So that will directly indicate that amount of carbon monoxide which is present. Just I am presenting the graph through which you can have a better idea. Say for example, if carbon dioxide is there, then it normally measures that 2000 to 220 2200 cm inverse of wavelength. Suppose ethane is present, then at 3000 centimeter inverse of wavelength of infrared light it will absorb. So what does we actually conclude with that this particular light is, if it is allowed to pass through that particular sample gas, the ethane will absorb the particular infrared light and it will raise its temperature. The temperature rise would be measured with the help of thermopile. So from that different setting different wavelength, we can evaluate different gases which is present in the exhaust gas. So that's all about the non-dispersive infrared analyzer. Now let us understand the second category, that is a flame ionization detector. This is actually used just to measure the hydrocarbon which is present inside the exhaust gases, right? Let us understand the setup. First of all, we are having one chamber like body, the below part at which we are having a burner. Now this burner is actually allowed to have the supply of air as well as the hydrogen fuel. We need to have three different constituents in order to have a fire. First we need to have a fuel, then we need to have air, and third one, that is an igniter. So here air we are supplying, then the hydrogen as a fuel we are supplying, and the igniter would ignite that particular fire. So lamp like a structure would be formed inside the particular chamber, but this lamp is formed with the help of a fuel material, that is hydrogen. That's why this flame is called as a hydrogen flame. Now this particular flame remains neutral under a normal running condition, but whenever the hydrocarbon molecule is allowed to pass, that will form the different ions in that particular atmosphere. Now this particular ions which is formed, that is been collected through the particular system, and the amount of ions which is actually been generated, that has been calibrated with the particular amount of hydrocarbon which is present inside the particular chamber, right? So in that particular way we are actually measuring the amount of hydrocarbon which is present inside the particular chamber. That's all about the today's presentation. Thanks for watching.